Today we are going to solve Leetcode 76, minimum window substring. So basically you've been given two strings, S and T, and you've been asked to find the minimum window inside the first string where you can find all the characters of T, right? So with this example we've been given here, we've been given S is equal to A, T is equal to A. There's only one window here and we're only looking for A, so this is the window that we find A. And then the third example we've been given here, S is A, T is A. Now we've been asked to find T inside S, and clearly we can see that T is longer than S, so this is not going to work, so you're going to return an empty string. But this lets us know that there is an edge case that we need to take into consideration, right? Now let's take the first example that says like Adobe Code Bank. So Adobe Code Bank, and then we've also been given T, so this is like S is equal to this, and they've been given T that is equal to A, B, C. Now if we count first, let me just get the indices of this. 4, 5, 6, 7, 8, 9, 10, 12. Now from this we can see that there's only one occurrence of A, there's only one occurrence of B, and there is one occurrence of C. Now what we want to do is look through these points, right? So we try to look through this. We set a right pointer and a left pointer, and then we look through this point until we get something that matches, right? So if we get A, one count of A, we know that we found one, so we just like 1. Now if we get one count of B, we know we found 1, right? So that is it. And then we find another count of C, one count of C, then we know we found everything, right? So basically we need to find a dictionary or key value pair that is similar to this. So we will have 1A, we'll have 1A, 1B, and 1C. So where can we find that, right? We can find that with this window, we can find that there's 1A here, and then there's 1B here, and then there's 1C, right? And if we find that we want to keep the length, right? And finding the length of an array is like right minus left plus 1. So in this case, the left is 0, the right is 6, is 5. So 5 minus 0 plus 1, 6. Now that we found it, we don't know if this is the shortest, right? We're trying to find the shortest, the minimum window, the shortest window, shortest length. So there's still stuff here that we can explore. So if we take this one out, let's say we move the left pointer here, now we only have 1B and 1C. This now becomes 0, right? 1, 1. So we need to move the right until we find another A, right? And we find something similar to A1, B1, and C1. And looking at this, the next place we can find that will be, it's 1B, the C here, it would be here up until here. It will be from C right here up onto A right here, right? And what is this? This is 5 minus 10. So that will be 10 minus 5 plus 1, and that's also 6. Now, we keep on moving here because we still have 6. We keep on moving here. Here we have 1C, 1B, and 1A. But if we move here, now this place becomes 0, right? And everything becomes 1. In order to turn this into a 1, it will come here, right? While the right is also moving. So the spot where we find our next spot will be here, right? And this is 12 minus 9 plus 1, and that is 4. So this is the spot. So clearly, so here we know this is the left pointer, and then the right pointer is here. Now the left pointer is also here for this one, and the right pointer is here. And similarly, we have a left pointer here and a right pointer here. So we see that we have like 3 windows. The algorithm for solving a question like this is called, solving a question this way is called sliding window. So we're going to use sliding window in combination with dictionaries to solve this question. First, make sure we have the counts in T, and for each window we get the count. If we get a count that matches this, we record that. We record the distance, and then after that we record whatever. So in this case, the shorter distance, if we want to record the shortest distance, is going to be as we described here. Let me bring it down a little bit. It's going to be 9, s of 9, 9 plus 4, right? Because this is 4, and then we started from here to here. So this is what we want to return, right? If we do find the minimum window that has all of this, right? So let's go to the code and see how we can represent that. So first, let's deal with the edge cases. If not T or not S, or length of T is greater than S, is greater than length of S, we return an empty string. Now we want to count the occurrence of each of the characters in T. So we want to do that. Let's do that. So we have T counts. It's going to be a dictionary. And for each window, we want to count the occurrence of characters that we are looking for, also as a dictionary. So for character in T, T counts character is equal to T counts dot gets the character, or 0 if it doesn't exist, plus 1. And then the window counts for that character is set to 0. Now, since it is sliding window, we are going to need our left and right pointers. So let's set our left and right pointers. Okay. And the required length of the dictionary that we need to form to know that we have gotten all the elements in A inside a particular window should be the length of this dictionary that we formed, right? So let's make sure we have recorded that. So required is equal to length of t count. Now, what you're going to do is start moving the right pointer. As we move it here, move it here, move it here, move it here, right? So we're going to start moving the right pointer. So while right is less than the length of s, character is going to be right. And then the window counts. As we move, we are counting of character is going to be equal to window count dot get the character 0 plus 1. Now, if character in t counts, if character is in t count and window counts of that character is equal to t counts of that character, then we know we have found one. So we need a found variable to keep track of founds. All right. Found is equal to 0. What we also need is we need to keep track of the length of the window, and we need to keep track of where each window starts. That keeps changing with the movements of the window. Here it starts at 0, here it starts at 5, and here it starts at 9. So let's keep records of that. So window minimum window length is equal to float infinity. So we're setting it as infinity because we're setting it as maximum as possible, positive infinity, because then we can easily get the first minimum from there. Nothing is going to be bigger than minimum infinity. And then we're going to get the window starts point. That is going to be equal to 0. So now what we are going to do is while left is less than or equal to right, and found is equal to what's found, and found is equal to required if, first of all, let me set this character is equal to s dot left. If right minus left plus 1 is less than minimum window length, then minimum window length is equal to right minus left plus 1. And the window start points is now equal to left. So the next thing we are going to do is start shifting the left, moving the left up. And we move the left by taking 1 out of the first element, right? So the value is decreased by 1. And what we're going to do here is to say Windows count of character -1. And if character is in T counts, character is in T count and window count is less than T count of that character. So Windows count of that character, the T count of that character. That would mean that found will increase by 1. Now if we shift this one the left by 1, A now becomes 0, right? The same way when we shifted this to this point by 1, C now becomes 0. So that's what we are trying to record here. So after this, the left pointer moves forward by 1, and then the right pointer also moves forward by 1. They will both be moving until we find a window, right? That's how sliding window works. After this, we return an empty string if minimum window length is equal to positive infinity. Else we return window starts, the starting points of where the left pointer ends, window starts, and then window starts plus minimum window length. So let's look at this. If not T and not S, we return that. We get all counts. T count, we get characters, window, we get window count. Get required, we get right, we start counting the window count for characters in T. If the character is in T count and the window is that, all right. If there are no typos, this should be all right. Awesome. Well, this is how you solve Leetcode 76. This is a hard problem, so it involves a lot. It took me a while to grasp this concept. So thanks for watching and see you in the next one.